This objective will be covered in 2 parts. At the end of this Part 1 video, you should start to be able to compare the characteristics of the outer planets. Chapter 27, Section 4, Jupiter. Jupiter, shown here, is the 5th planet from the Sun, and is by far the largest planet in the solar system. Its mass is more than 300 times that of Earth, and is twice that of the other 8 planets combined. Jupiter's orbital period is almost 12 years. Jupiter rotates on its axis faster than any other planet rotates, once every 9 hours and 50 minutes. Jupiter has at least 60 moons, 4 of which are the size of small planets. It also has several thin rings that are made up of millions of particles. Jupiter's atmosphere. Hydrogen and helium make up 92% of Jupiter, so Jupiter's composition is much like the Sun's. However, when Jupiter formed about 4.6 billion years ago, it did not have enough mass to allow nuclear fusion to begin. So, Jupiter never became a star. The alternating light and dark bands on its surface make Jupiter unique in our solar system. Orange, gray, blue, and white bands spread out parallel to the equator. The colors suggest the presence of organic molecules mixed with ammonia, methane, and water vapor. Jupiter's rapid rotation causes these gases to swirl around the planet and form the bands. The average temperature of Jupiter's outer atmospheric layers is negative 160 degrees Celsius. Jupiter also has lightning storms and thunderstorms that are much larger than those on Earth. Weather and storms on Jupiter. Jupiter's most distinctive feature is its Great Red Spot, which is shown here. The Great Red Spot is a giant rotating storm, similar to a hurricane on Earth, that has been raging for at least several hundred years. Several other oval spots or storms can be seen on Jupiter, although they are usually white. Sometimes the smaller storms are swallowed up by the larger ones. While storms are common on Jupiter's surface, only a few of the largest storms persist for a long time. A probe dropped by the Galileo spacecraft measured wind speeds on Jupiter of up to 540 kilometers per hour. Because winds are caused by temperature differences, scientists have concluded that Jupiter's internal heat affects the planet's weather more than the heat from the Sun does. From Earth, even by using a small telescope, you can see bands of clouds on Jupiter. These bands, which vary depending on latitude, show regions of different wind speeds. Jupiter's interior. Jupiter's large mass causes the temperature and pressure in Jupiter's interior to be much greater than they are inside Earth. The intense pressure and temperatures are as high as 30,000 degrees Celsius, which have changed Jupiter's interior to a sea of liquid metallic hydrogen. Electric currents in this hot liquid may be the source of Jupiter's enormous magnetic field. Scientists think that Jupiter has a solid, rocky, iron core at its center. Saturn. Saturn, shown here, is the 6th planet from the Sun and has an orbital period of 29.5 years. Because it is so far from the Sun, Saturn is very cold and has an average cloud top temperature of negative 176 degrees Celsius. Saturn has at least 60 moons, and additional small moons continue to be discovered. Its largest moon, Titan, has a diameter of 5,150 kilometers, which is half the size of Earth. Saturn, like Jupiter, is made almost entirely of hydrogen and helium and has a rocky iron core at its center. However, Saturn is much less dense than Jupiter. In fact, Saturn is the least dense planet in the solar system. Saturn's bands and rings. Saturn is known for its rings, which are 2 times the planet's diameter. While the other gas giants also have rings, Saturn has the most complex and extensive system of rings. The The rings are made of billions of dust and ice particles. Most of the ring debris probably came from comets or other bodies. Like Jupiter, Saturn also has bands of colored clouds that run parallel to its equator. These bands are caused by Saturn's rapid rotation. Saturn rotates on its axis every 10 hours and 30 minutes. This rapid rotation, paired with Saturn's low density, causes Saturn to bulge at its equator and to flatten at its poles. Scientists are learning more about Saturn and its moons from NASA's Cassini spacecraft, which reached Saturn on July 1st, 2004. Cassini also carried the European Space Agency's Huygens probe, which landed on Titan, which is Saturn's largest moon. At this point, you should start to be able to compare the characteristics of the outer planets.